So let's talk about a new idea that is frankly mind-bending. It's a way to give AI what is essentially a perfect, infinite memory. This is called recursive language models, and it could seriously be the next big thing in artificial intelligence. But first, have you ever stopped to think about this? It's kind of a paradox, right? We've got these incredibly powerful AI models. They can write code, they can make art, they can reason about all sorts of complicated stuff. And yet, if you ask one to read an entire novel, by the time it gets to the last page, there's a good chance it's completely forgotten key details from the first chapter. And this isn't just some small little glitch, it's a huge bottleneck holding the technology back. All right, let's get right into it. The heart of the issue is something researchers call the LLM memory problem. It really all comes down to how these models deal with long streams of information.
And there's a fantastic name for this specific kind of failure: context rot. I love that. It perfectly describes what happens. As you keep feeding an AI more and more information, even when you're still within its official memory limit, its context window, its ability to recall and use the stuff from the beginning starts to decay. It literally just rots away.
Now this is where it gets really interesting. Look at the difference here. A standard large language model, even a super advanced one, its performance just falls off a cliff as the text gets longer or the task gets more complicated. But a recursive language model, or RLM, and this is the key part, using the exact same AI brain, stays strong and stable even with enormous amounts of information. This tells you something absolutely critical. The problem isn't the AI's intelligence, it's the method it's using to read.
So what's the fix? Well, researchers have come up with a totally new way for an AI to think about information. It's a complete shift in perspective.
This quote from the research paper is really the whole idea in a nutshell. It's a total paradigm shift. Stop trying to cram the entire book into the AI's short-term memory. Instead, treat the book like an external tool, like a file on your computer. Suddenly, the AI isn't just a reader anymore. It becomes a researcher with access to an entire library. And this analogy just nails it. A standard LLM is like someone trying to speed read a textbook and memorize it all in one sitting. It's an impossible task. You're bound to forget stuff. The RLM, on the other hand, is like a meticulous researcher. It reads a chapter, jots down some notes, and if it needs to check a fact from chapter 1 later on, well, it just flips back to that page. It has a system. It's working smarter, not harder. Okay, so this whole researcher model sounds great in theory, but how does it actually work under the hood? Let's break down the mechanics. Now, this diagram might look a little complicated at first, but the core idea is actually really simple. The long prompt, let's just call it our book, it doesn't get fed directly to the AI. Instead, it gets loaded into a basic programming environment. From there, the AI can write little bits of code to interact with the book, asking it things like, show me the first paragraph, or find every time the name Sarah appears. And here's the crazy part. It can call on a fresh copy of itself to analyze just those little pieces. Let's walk through this. First, that huge prompt just becomes a variable, like X in a math problem. Second, the main AI writes some code to explore X. Third, and this is the recursive magic, it calls a fresh copy of itself to work on a tiny, manageable chunk, asking it a very specific question like, hey, summarize this one chapter for me. That little sub-AI gives back an answer, and the main AI takes notes. And finally, after doing this over and over again, the main AI looks at all its notes and synthesizes the final complete answer. It's this constant loop of reading a command, evaluating it, and printing the result, a process that lets it interactively solve a massive problem piece by piece. All right, so that's the theory. Super clever, right? But does it actually hold up in practice? Well, the researchers put this new method through some incredibly tough tests to find out. And the results? I mean, look at these numbers. They are absolutely wild. On a really complex task that required the AI to find and compare related bits of information scattered across a huge document, the base model just completely failed. A score of 0.1%, it's basically guessing. But the RLM, using that very same AI as its engine, scores 58%. That's not just a small improvement. That is the difference between total abject failure and genuine competence. And we're not just talking about quality, we're talking about sheer scale. This recursive approach allowed the AI to process documents that were over 100 times larger than its original memory limit. Think about that. That's like going from being able to read a long magazine article to suddenly being able to analyze an entire encyclopedia. And get this, it gets even better. The researchers found that you can actually train models to get better at this whole recursive process.
With just a little bit of specialized training, a smaller open-source model got over 28% better at being an RLM. This suggests we can one day build AIs that are natively good at this new way of thinking.
So the takeaway here is that this is way more than just a clever hack. This really points toward a future where AI capability can scale in a completely new direction.
And for me, this might be the most exciting part of all. When given this new toolset, the AI started developing its own smart research strategies, all without being explicitly programmed to do so. It figured out how to use advanced search commands to filter out irrelevant junk, and it even learned to group similar questions together to search the text more efficiently. It started acting like a skilled human researcher, all on its own.
So let's just step back and think about why this is such a big deal. For one, it unlocks tasks that were just impossible before. Like asking an AI to analyze a company's entire software codebase, it allows for much deeper, more complex, multi-step reasoning. And maybe most importantly, it gives us a brand new way to make AI smarter without just building bigger and bigger models. The next frontier might not be a larger AI, but a recursive one. Which really just leaves us with this final thought. For so long, we've been constrained by the limits of an AI's memory. But what happens if that limit is effectively removed? What kinds of impossibly complex problems, in science, in medicine, you name it, could we finally ask an AI to solve? The possibilities are, well, recursive.